Well, hello, welcome back. We're going to be putting a lot of things together now. I've been telling you that this has been on the horizon. So today we're finally going to take a lot of what we understand about ions and kind of put it together into something useful. And that is to figure out what we call the formulas for materials made from ions. So we call these things ionic compounds. All right, so we're going to write ionic formulas for ionic compounds. Lots of different materials in the world are really just these things called ionic compounds. And you can think of the formula as almost like the recipe for them. It's like, what do you need to put together chemically in order to make this particular compound? Most common example people use is regular old table salt. You know, what you shake on your food or put in your food as you're cooking. Its chemical name is sodium chloride. It's an ionic compound, and it has a recipe, if you will, for how we put that together. So I'm going to show you sodium chloride, and as I do that example, I'm also going to be making a list that you will follow for other examples, because this is not something you just do one time and you memorize like for sodium chloride. This is a process you have to learn, and so that once you learn the process, you can write the formulas for dozens and dozens of different compounds, okay? And then once we've kind of written that list and done the first example, then I'll take you through a couple additional examples that are a little different, and the more challenging stuff is at the end. So you can't just watch it once and think, oh, this is easy and I got this. You really, unfortunately, are going to have to watch to the end, and yes, I know this video is going to go a little long, and that's because I want to be detailed about things to do and things not to do. At the very end, I'll show you some of the common mistakes people make that I want you to avoid, okay? So let's get started with understanding the formula or recipe for sodium chloride. So on this page here, the first page, I want you to write the steps. And then as I work through these steps, I'm going to flip to another page, and I want you to do that as well. You can even have a page next to this so that we can do an example of what that step looks like, okay? So here's our first step. We're going to write symbols and charges for the metal and nonmetal ions. Okay, so you're going to write that, copy it down, and then we'll go on to another page and I'll show you what that looks like for our first example here. Okay, so on another page, again, kind of flip over so that you can keep this list and not clutter it up with our example here. So our first example is going to be the formula for sodium chloride. Okay, this is going to require that you have a periodic table close by. I'll just use a paper version, whereas you can use an online version if you want to. You're going to have to find these elements on the periodic table, okay? Because these ions are made from atoms of particular elements. So the sodium one is kind of hard because its symbol doesn't start with S. Symbol is Na. So sodium is here. So make sure you have a periodic table that has the names on it. So the symbol is Na, and we're also going to include the charges on the ions. So this is why we spent a long time learning about the periodic table and what it tells us about electrons and charges. So let me kind of refresh your memory on that. Because sodium is part of group 1, the first column here, all these elements have one outer electron. So can you see on sodium here, it says 281. That's where the electrons are located. So it is going to lose that one electron in order to become a positive ion, a positive 1 ion. So we're going to write the symbol for a positive 1 sodium ion. So it looks like this. Okay, now you say, well, what is chloride? Well, chloride is not the name of an element, but you have to know that for all the nonmetals, when they form ions, we change the ending of their name to IDE. Okay, so you'll see chloride, but that really comes from the atom we call chlorine. So here's chlorine. I know it's hard to read this. This says 287. 7 outer electrons. And everything in column 17 here, group 17, has 7 outer electrons. Well, so what do those want to do? Remember, they're trying to acquire a full outer energy level, which means 8. So it's very, very close, but not quite there. So chlorine atoms will acquire 1 more electron to go from 7 up to 8. And in doing so, they end up with a charge of a -1. So we still write the same symbol. Again, it's still chlorine, it just changes its ending to IDE when it becomes an ion. Okay? And it is a -1 charge. All right? So all your metals on the left side of the table will end up being your positive charges, and all the nonmetals on the right side of the table will end up being your negative charges. Okay? And we're doing an easy one here with just a 1 and a 1 to start with. All right. We got that part done. Let's take a look at step 2. All right. In step 2, we have to make a decision. So here's what we do. We first look at this. If the plus and minus charges are the same, go to step 3. If not, and I'm going to hold off there because that won't pertain to our example here. Okay? So we're going to add to that in just a moment, but let's go back to our sodium chloride example first. Okay, so notice our +1 and our -1, those are identical charges, 1 plus and 1 minus. So that means we're going to get to move right on to step 3. But I want to leave some space here to write the rest of step 2. Okay? So we're going to skip a little and then we'll write step 3. All right, here's what we do in step 3. We write the symbol for the metal, and then the nonmetal. No spaces, no charges. I'll put that in parentheses. So we don't include spaces, we don't include charges. So what is this going to look like for our sodium chloride example? Again, we get rid of the charges. We're not going to write those in our formula. We're just going to take all the space in between these, and we write NaCl. Now, something you've noticed, but I haven't really pointed out real strongly, is that when we write a 2-letter symbol, we always have a capital first letter and a lowercase second letter. So that's why the chlorine, 2 letters, is capital C, small case l. Okay? All right, so let's look at another example. And this is going to be one where we're going to have to add a little bit to parts 2 and 3 in our steps. Okay? So another example, we'll call this number 2. Let's look at the formula for magnesium bromide. Do you recognize the elements where those names come from? Again, you got to find this on a periodic table. All right. So the first step is to find these elements, write the symbols and charges so that we know what ions we're dealing with. So here's magnesium, Mg. I want to caution you that there's manganese that looks very similar. It's Mn over here. But magnesium, that's in column or group 2, which means it is going to lose 2 electrons in order to become an ion. And it will end up with a +2 charge. So the magnesium ion, we would say, is Mg +2. And what about the bromide ion? Well, it's right below chlorine. So it's very similar to chlorine in that it's in the same family. This is the family here that gains 1 electron. And so, again, we're not writing the formula yet. We're just writing the information we need to figure out the formula. So that's what we did here. Okay, writing the symbols. All right, let's go to step 2. If the plus and minus charges are the same, go to step 3. Well, this time they're not. We've got more of the pluses and fewer of the minuses. So we need to add to step 3 now. Or, sorry, step 2. All right, so here's what we'll add. If the charges on the two ions that you're dealing with aren't identical, here's what we need to do. We need to write more ion symbols until the plus and minus add up to the same number. Now I'm going to show you what that looks like in our magnesium bromide example, but just get this down here, and then I'll show you what it looks like when we do this. And pause here if you need more time to write this down so you don't get lost as I move on. Okay, so what we're going to do is we're going to write more ion symbols. Okay, so these are the ion symbols that we're dealing with here. We're not going to make up new ones. We're just going to write more of these. So we got to look. We want to end up with the same number of pluses as we have minuses. Right now, we've got 2 pluses, but only 1 minus. That tells you you need to add another of the minus symbols. So we're going to write it like this. See how we're just writing the exact same thing? All right, now let's look what our pluses and minuses are. We have a total of +2 from this one magnesium ion, and we have a total of -2 because each of these bromides has -1. So we've written enough ion symbols to where the pluses and the minuses add up to the same number. 2 pluses and 2 minuses. Okay? All right. So now we're going to also modify step 3. We're going to write the symbol for the metal and then the nonmetal, and we're still going to do that. We don't put spaces in between it, so we write Mg, Br. We don't put the charges on there. Remember, capital letter on the first letter of a symbol and the small case letter for the second. Okay? But here's what we do that we didn't do in the sodium chloride example. With small subscript numbers, again, I'll explain all this in just a minute, to show how many of each ion. Okay, again, write that down so that you have it down, and then I'll show you how I'm going to modify the formula just a little bit to account for this little change. Okay, small subscript numbers to show how many of each ion. All right, hopefully you got that down now. So a subscript, sub means below, and script means to write. Okay, so what we do is we write little numbers right after each ion if and only if we have more than one of those ions. So we only have one magnesium, so we don't need to write anything for it. But because I had to write 2 of the bromide ion symbols, I want to show in my formula that I need 2 of those. And so right after the Br, no space or anything, just down kind of in the corner, I write a little 2. All right? And all of you have heard of this before. You've heard of H2O. Well, that 2 is a subscript number when you write the formula. It says 2 H's for every O. This is very similar. This is MgBr2. It means I need 2 bromide ions to go along with 1 magnesium ion. Now let's get into what's actually happening here when these ions form. Remember that magnesium is trying to get rid of 2 electrons. So how can it do that? They got to go somewhere, right? Well, these bromines are floating around there in the world, and they're looking for 1 electron. So I don't think the bromine is not able to take both of the electrons from magnesium. But if there were 2 bromines, we could have 1 bromine take 1 of the electrons, and the other bromine take the other electron, and then the magnesium's happy because it got rid of 2, and the bromines are each happy because they each got 1. That's sort of how we come up with this recipe for how many of everything it takes. And there's our formula, MgBr2. Okay? I'm going to add here, don't write subscripts of 1. We never put a subscript of 1 in. If we don't write anything there, we mean 1. Okay? All right, so let's look at a third example for it, and we just kind of put this all together. And I'm not going to flip back to this page now. Example number 3. Let's do a sodium oxide ion, or sodium oxide compound, we call it, an ionic compound. So we're going to write the symbols of the ions involved. Now we've already done sodium. That's the one that we did in our first one. So its ion symbol looks the same, Na+1. Now what's oxide? Well, you have to know that the name oxygen turns into oxide when it forms an ion. So we're going to find oxygen here on the periodic table. Here it is in column 16 with its electrons of 2 and 6. Now again, think about this. How can it most easily acquire a full outer energy level? It needs to get 2 more electrons. So it's looking for 2 somewhere. Where could it get 2 electrons from? Ah, there's some sodium around trying to get rid of an electron. All right? So this is why these compounds form. They both kind of help each other out. You scratch my back, I'll scratch your back. Or in this case, you give me an electron and I'll take an electron, and everybody's happy. So we're going to write the symbol. Now, what kind of ion will this be if it acquires 2 electrons? That's 2 more negative charges than it started with, right? So the symbol for that ion is O minus 2. All right? Now notice these charges are not identical to each other, so we have to write more ion symbols until they are the same total number. This time, though, we don't need more of the nonmetal oxygen. We need more of the plus ion because that's the one we're deficient in right now. So if we write another identical symbol like that, now I've got +1, +1. That's a total of 2 pluses. And I've got over here still 2 minuses. That's when we show that we have as many pluses as minuses, and we can write our formula. We write the metal symbol first, Na, and then the nonmetal, O, and then we count how many of each one we have. We have 2 of these and 1 of these, and we never write 1s in, but we will write 2 in after the sodium. So we're showing we need 2 of these Nas in order to bond with 1 of the O's. Okay? All right, I'm going to do the hardest example next. Okay? I promise you will never have one worse than this. So if you can figure this out and watch me closely, you'll be able to figure out any of the ones I give you. All right? So we'll do that one, and then I'll run through the errors to avoid, the fixes that I always end up having people do, and I want you to avoid those by watching out for those. Okay? All right, so let's look at our fourth example. All right, here we go. Magnesium phosphide is going to be the compound we want the formula for now. All right, so magnesium, again, I picked one on purpose that we had seen before so that we can remember its symbol, Mg+2. It lives in group 2, and so it's going to be giving away 2 electrons to form the ion called magnesium +2. Now, phosphide we haven't seen yet. It's related to or comes from the atom called phosphorus, and here that is in column 15. Well, what does a phosphorus do if it's got 285? 285. It's really difficult to lose 5 electrons, and so if it just acquires 3 more, it will become an ion, and it will be a happy ion because it'll have a full outer energy level. 3 more electrons means phosphorus, just got 1 letter, is a -3 ion. Okay? So in step 2, we look to see whether we have identical plus and minus charges, which we don't. In fact, these are about as different as can be. But again, this is the worst you'll have, is like a 2 to 3 or 3 to 2. So now we got to write more ion symbols until the total number of pluses and the total number of minuses is the same number. Well, you might look and say, okay, I can see I don't have enough pluses now because there's only 2 of these, but 3 of those. So I'll write another one. But this isn't going to cut it now. In our previous examples, just putting 1 more symbol down seemed to get it for us. But now we've got +2 and +2. That's 4 pluses, but only 3 minuses. So now I need more minuses. Okay, there's no rule that says you can't write another ion symbol for that one. So now I have a total of 4 pluses, and now I have 3 and 3 is 6 minuses. Or think of it this way. We got magnesium's willing to give away 4 electrons, but phosphorus is looking for 6 electrons total. Well, that means we just need to go back and add more of the metal ion. And this will be the worst you'll ever have. 3 of one and 2 of another. Okay? If you ever have more than that, you did something wrong. So now we have a total of 6 electrons being given away, 6 electrons being taken. Perfect. So we write the metal ion symbol, Mg, and then the non-metal symbol, P, with no space in between. Got the lowercase g in there. And we write how many of each it takes in order to make everybody happy. Well, we've got 3 magnesium ions, so that's a 3, and we've got 2 phosphorus. That's 2. So we say Mg3, P2. All right? So there you go. So the worst you'll have is 3s and 2s. If you ever see 4s, 5s, and 6s, you did something wrong. Don't let yourself do that. Okay? All right, so let's make a short list of things to watch out for and not do when you're writing your ionic formulas. All right, these are things I've mentioned already. First of all, no charges. We don't write the charges on the formulas themselves. We can write them as we're working. This is just our working stuff, but this is the final answer. No charges on there. No subscript of 1. If you mean that you have 1 of something, just don't write anything at all. You can write 2s and 3s, but you'll never write a 1. Okay? Write the metal first, then the non-metal. The thing giving away electrons, and then the thing taking the electrons. Okay? And let me write it this way. Don't confuse charge with subscript. Now I'm going to tell you exactly what I mean by that one. Don't mix up the charge with the subscript. Here's the one right here. Notice the charge on the magnesium was +2. The subscript on magnesium was not 2, though. It was 3. The subscript is a counting number. How many do you see on your paper? 1, 2, 3 of them. How many phosphorus or phosphide ions? 2 of them. That's what we're putting in as a subscript. Okay? All right, so I know that was a lot. 23 minutes is as long as I've gone, but I needed to show all the examples because I want you to be able to handle the worst case scenario. All right? You might need to play this again if you get stuck on one. I'll give you plenty of opportunities to practice, but once you master the process, you could do this with any combination of metal ions and non-metal ions at all. Okay? All right, that's good for now. On to your practice.